Okay, so in today's video we're going to look at how to find the angle between two vectors. We already know how to find out if a pair of vectors are perpendicular to one another by taking the scalar product or the dot product, and of course if that's 0 we know that they're perpendicular, but we don't know how to find out the angle between two vectors that might not be perpendicular, or the angle between any two vectors. So let's change that to black. So, in today's video, I'm going to show you how to do that. Here we have the angle phi between the two vectors A and B. First of all, we need to find the components of A and B. So, vector A has components 5, -3, and B has components 2, 4. Now there's a nice handy formula for you to put these things into to show you the angle between two vectors. I'm not going to show you where the formula comes from in this video. We need to do a little bit of work on trigonometry first, which I plan to do in the IB coaching time that we have together. And I hope that once we've covered that in the IB coaching time, you'll be able to tell me where the formula comes from. So, I've already given you a hint that it involves trigonometry, and it involves the cosine of that angle. So the cosine of the angle phi is equal to the scalar product of A and B divided by the absolute value of A multiplied by the absolute value of B. So let's see how that works in practice. In this case, we have the cosine of phi is equal to 5, -3 times by 2, 4, divided by the absolute value of A, which would be 5 squared plus -3 squared. So in this case, we have 25 plus 9, the square root of that, which would be 34, multiplied by the square root of 2 squared plus 4 squared, so 20. Our scalar product in the numerator gives us 5 times 2, which is 10, plus -3 times 4, which means we need to take away 12 from that 10, divided by the square root of 34 times the square root of 20, which gives us -2 over root 34 times root 20, and this is something we can do on the calculator. So we have root 34, and don't forget to put brackets after it, multiplied by root 20 gives us a square root of 680. 2 divided by that gives us 0.0766, and of course it's -2, so that's a negative answer. 0.076696. I'll keep a lot of decimal places here. So now all I need to do to find phi is do the inverse cosine of -0.076696 in my calculator, and I should be able to find out what phi is, and I get 94.40 degrees if I round it to 2 decimal places. 2 decimal places. So we found that this angle, although these two look perpendicular, they're not perpendicular. I've actually found the angle between them. Let's do one more example. I'll take one from the book this time. So we have 13.37, and let's do exercise F, which gives us two vectors. A is -3, -5, and B is 6, -2. Can you remember the formula that you need? See if you can remember it for yourself, and I'll write it up here. This is a formula that you'll be given in both the IB exams and the Matura exams, so you don't need to remember it off by heart, but I would recommend that you are at least familiar with it, and if you can remember it, it would save you time in exams. So, in this case, the cosine of the angle would be -3, -5 times 6, -2, divided by the absolute value of A, which again would be the square root of 34, times the absolute value of B, 6 squared plus -2 squared gives me the square root of 40. So the cosine of my angle is -3 times 6, which gives me -18, plus -5 times -2, which is +10, all over the square root of 34 times the square root of 40, which is actually the square root altogether of 1360. So I have -8 over that, which gives me -0.2169 to 4 decimal places. Then I need to do the inverse cosine of the number that I just got, so -0.2169. And hopefully you'll get the same as me if you put it in your calculator, that you get the angle as being 102.53 degrees to 2 decimal places. If we wanted a geometric representation of what's going on here, because we have the vectors in this notation, it means that we don't have any kind of starting point. So let me just draw a sketch here. As always, you'll be able to do a neater one in your books. So I can choose my starting point for both, maybe as being the origin. So if I did -3, -5, and ended there, my vector A, should be a straight line, and should look something like that. For B, if I had 6, -2, it would end about there-ish. Again, with squared paper, you'll be able to do it much more easily. My vector B is there, and you can see that it looks about right, that the angle between them is 102.53 degrees. I always recommend doing a sketch either before or afterwards to get a feeling for the problem, and to check your answer. See if it seems sensible within the context. If you ended up here with A and B being, like this, and your calculation told you that this should be 102.53 degrees, then something must have gone wrong somewhere. So I recommend checking it in both ways. And the final thing I wanted to say about this is that from this formula, it also shows us why, if the scalar product is 0, the angle is 90 degrees. So if the scalar product between two vectors is 0, then the cosine of the angle would be 0 divided by the absolute value of A times the absolute value of B, which would be 0. And of course, if the cosine of the angle is 0, that means that the angle itself would be 90 degrees. So we can also see that if A and B is 0, that means that our angle between A and B has to be 90 degrees. So that comes to the end of introducing this formula to you. If you have any questions, again, as always, please write them in your book. We'll be having a look at this again in the lesson time, but it's not something I want to spend too long on, and we're almost ready to move on to the next chapter of our book. So if you feel like you need a bit more practice in this, I suggest doing 1 or 2 exercises on your own, and we'll talk about it briefly next time in class.